All right, we have time for one more quick one. So let's say, claim. The integers are closed under division. What does that mean? That's one of those things where it sounds, this is like something I'd read in a textbook and my mind would just go over and over again. Like it sounds simple enough. You read it and go, oh, okay. Wait, what? What does that mean? What's it mean for the integers to be closed? What's it mean for a set to be closed under some operation?
Does it mean like we can take any two integers and just divide and divide and divide and we'll stay within the integers?
Exactly. That's exactly what it means. Like saying, like, if you have set S is closed under an operation, let's call it star, means for all X in S and Y in S, X star Y is in S. It's closed in the sense that you can't get out of S by just dividing or just using this operation. So my claim is that that's true for the integers. What do you guys think? True or false? Actually, let's first write it formally. So formally, what I'm saying here is for all X and Z and for all Y and Z, which is the integers, X over Y is in Z. Aside, what do we think? I mean, for example, 4 is in Z, 2 is in Z, and 4 over 2 equals 2 is in Z. So there's definitely some integers that you can divide and get other integers out, but is this true always?
No.
No.
Give me an example.
2 over 3.
Any
2 over
odd
3.
integer with 2.
What?
Any odd integer with 2.
Yeah, exactly, right? So 2 over 3 is not in Z. Any odd integer like 17 over 2 is not in Z, etc. Right, so we found these examples. So to disprove a universal statement is really easy. Just find an example. So I'll say proof. Or disproof, actually. Disproof. Let X equal 2 and Y equal 3. Now note, whenever you're doing an example or a counterexample, the first thing you have to do is, so the negation, this is the thing we're proving. The negation is there exists an X and Z, and there exists a Y and Z, such that X over Y is not in Z. All right, that's what we're trying to prove. Or that, like, to disprove means to prove the negation. So that's what we're proving in the disprove. So the point is we're trying to find an X and Y that's in Z. And so whenever we do that, we kind of make a claim like let X equal this, let X equal 2 and Y equal 3. We're defining X and Y to be this, but to start off, to show that we're actually proving this negation true, we need to first just explain why our example actually is in the domain we want it to be in. And this time it's easy because we can assume, like, we're in this class, we're allowed to just look at integers and say that's an integer, right? But, you know, if it was something with rational numbers, we'd have to make some argument of why it was a rational number. Or if there was a claim about even numbers, we have to make an argument about why our numbers are actually even. So let x be 2 and y equal 3. Note 2 and 3 are even as required. Then I'll say, however, x over y is 2 over 3, which equals 0.6 repeating, is not an integer. Thus, there are integers, mainly x and y, such that x over y is not an integer, so claim is false. Any questions? So what's easier to prove? Universal statement or existential statement? I'm sorry. Is it easier to prove a universal statement or disprove a universal statement?
Definitely disprove.
Definitely disprove. Which one's more satisfying?
Prove.
Prove, right? Thank you. And by the way, disprove is easier to write, but sometimes it's actually harder to do because it requires you to find an example. And this is kind of an easy example, but when you're getting into high-level math and there's claims, the claims that exist are probably not obvious. People don't know if they're true or false, right? And so there might be a disproof that's just really hard to find, like a needle in a haystack. And so sometimes it is easier to prove something than disprove it. If you're trying to prove something, it's kind of like something only has a few properties. And you're trying to combine these properties in a certain way to get to your result. But to disprove, it's like, okay, here's the infinitely many integers, find the one that fails. That could be harder. But anyway, what time is it? 3:30. That is class. A little teaser for next time on Thursday. Yeah, exactly. On Thursday, well, that's true. You're right. That guy that disproved, well, theoretically though, maybe that it took that guy more than 300 pages of work to find a disproof. But then once you found it, you have to write it down. But anyway, a little teaser for next time. We'll prove the digits of any 4-digit multiple of 3 sum to a multiple of 3. That's pretty cool. But yeah, that is class. Have a great day, everybody. Thanks for showing up. Anyone have any questions? Anyone have anything? Like, anyone have anything they want to be proved? They have an idea they think is true, and they want to see if I can prove it. Show you the power of math, like some sideshow act. If you do, email me. We'll talk about it. And don't give me like the Raymond Zeta hypothesis or something like that. But yeah. Thanks, everybody.